Before we dive into the statement, it is important to first understand what particle accelerators are. The Gigantic Hadron Collider, LHC, operated by CERN, is a 17-mile ring of superconducting magnets. It is the world's largest and most powerful particle smasher, representing the peak of human scientific achievement. In fact, it's so powerful that it could recreate the conditions of the first moments of the universe. Yet, could this machine designed to uncover the secrets of the universe hold the key to something much more? CERN, founded in 1954, is one of the world's most renowned research organizations. With 23 member states and countless scientists, it is a center for collaboration and development. The LHC is CERN's flagship project, but it is just one part of a vast network of particle accelerators and experiments. Imagine a course not for vehicles or planes, but for subatomic particles, in a test of expertise, perseverance, and even the fabric of space itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that replicates the energy of the universe at the moment of the Big Bang. The effects create temperatures many times hotter than the core of the Sun. An array of magnets guides the protons on their journey, while complex cooling systems maintain temperatures colder than space. The beam inside the LHC is designed to crash at 4 locations around the accelerator ring, corresponding to the positions of 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each detector has a unique purpose, investigating different aspects of particle physics. Together, these detectors act as colossal cameras, capturing images of these collisions. Researchers then sift through the debris, looking for signs of the elusive Higgs boson, also known as the God particle, and other anomalies that may reveal the universe's fundamental building blocks. By focusing on the microcosm, we gain insights into the universe. However, with each answer comes another question, and with every discovery, another test arises. The LHC is not just a scientific instrument, it is a demonstration of human curiosity and progress. It embodies our relentless drive for knowledge and our desire to understand the key forces that shape the universe. However, as we push the boundaries of what we know, we must also consider the ethical and existential questions that arise. In the hallowed halls of CERN, where the limits of human knowledge are constantly tested, a revelation has emerged that has left even the most prepared scientists uneasy. Brian Cox's chilling statement. Brian Cox, a former researcher at CERN and an expert in particle physics, recently made a statement that both captivated and unsettled the world. His words resonate with chilling clarity. Yes, you heard that right, a miniature version of the very event that gave birth to our universe. Cox also discussed the implications of this objective, highlighting the LHC's extraordinary potential for making groundbreaking discoveries, such as unlocking the secrets of the Higgs boson and exploring dark matter, a mysterious substance that constitutes much of the universe. Imagine holding the power of creation in your hands, the ability to conjure the very essence of the universe. It's an alluring prospect, but one fraught with risk. The miniaturized Big Bang is not a hypothetical concept, it is a tangible reality within the LHC. The temperatures, pressures, and raw energy inside the LHC replicate the conditions that existed at the birth of the universe. It is like standing at the dawn of history, witnessing the birth of existence itself. However, with such power comes immense responsibility. A terrifying incident from 1978. In fact, something did go terribly wrong back in 1978. The Russian physicist Anatoly Bugorsky experienced a catastrophe that would forever alter the course of his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a misfire caused a proton beam to strike him directly. The beam passed through his skull, entering the back of his head and exiting through his nose. Despite the horrific injury, Bugorsky remained conscious, even walking to a treatment center. His intellectual faculties remained intact, though the beam caused localized tissue damage, leading to hearing loss in one ear and partial facial paralysis. This incident serves as a stark reminder of the immense power and potential dangers of particle accelerators. The risks associated with a particle smasher like the LHC are not to be underestimated. The fear of miniature black holes. One of the most disturbing and intriguing concerns related to the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so intense that nothing, not even light, can escape. These cosmic entities are vacuum cleaners, devouring stars, mysterious forces lurking in the depths of the universe. The idea that the LHC could potentially create such an entity even on a small scale, is staggering to both the public and scientists alike. Could this black hole grow uncontrollably, eventually consuming the Earth from within? Scientists at CERN have assured the public that any black hole created would be unstable and would disappear quickly. Nevertheless, this remote possibility has sparked fierce speculation and awe at the power we wield. Understanding how the LHC could create a black hole involves the basic principles of particle accelerators. When protons are smashed together at nearly the speed of light, the energy released is so enormous that it bends the fabric of spacetime itself. Think of a trampoline stretched tight and then dropping a heavy object onto it. The fabric bends. If the object is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. This is a simplified analogy for what could happen at the LHC, where, in the realm of quantum physics, the laws of the universe behave in strange and wondrous ways. Theoretical risks and scientific caution. There is a theory that extra dimensions may exist within our reality, hidden from view. If these dimensions exist, the LHC's experiments could tap into them, creating a gravitational well that forms a small black hole. This strange behavior has caught the attention of some prominent scientists, including the late Stephen Hawking. In his writings, he warned that the Higgs boson could become unstable at extremely high energy levels, leading to catastrophic vacuum decay, an event that would not just destroy the Earth but could potentially destroy the entire universe. Sir Martin Rees, a renowned English cosmologist and astrophysicist, also expressed concerns about experiments at CERN. In his book Our Final Hour, he described a worst-case scenario where a failed experiment could create vacuum instability, triggering a phase transition that would ripple through spacetime, potentially engulfing the entire universe. Although Rees assigned a low probability to these disastrous outcomes, he argued that even a small possibility should be taken seriously. It's easy to be swept away by sensational headlines and fears of global catastrophe. However, the truth is that the scientists at CERN are acutely aware of the risks involved. They have taken every precaution to ensure that their experiments are safe. The potential benefits of this research breakthroughs in our understanding of the universe, the discovery of new particles, the exploration of dark matter, are truly extraordinary. The LHC represents the cutting edge of scientific inquiry where theoretical physics meets experimental reality. It is a symbol of human curiosity, our drive to understand the universe in its most fundamental form. The LHC and the nature of reality. At its core, the Large Hadron Collider is a machine of discovery, probing the deepest layers of reality. But what if, in its quest to unlock the secrets of the cosmos, it uncovers something unexpected, something that challenges our understanding of existence itself? One of the most fascinating aspects of modern physics is the idea that our universe may not be the only one. Multiverse theory and the LHC. Some scientists speculate that the LHC's high-energy collisions could provide evidence for the multiverse, a concept suggesting that our universe is just one of many parallel realities. This theory arises from string theory, which posits that extra dimensions may exist beyond the familiar three of space and one of time. If these extra dimensions exist, then certain particles or energy signatures generated within the LHC could vanish into them, providing experimental proof of their existence. In this scenario, the LHC could act as a gateway, not in a science fiction sense, but as a scientific window into the structure of spacetime itself. These are profound questions that push the boundaries of physics, philosophy, and even metaphysics. The LHC and the search for dark matter. Another key mystery that scientists hope the LHC can solve is dark matter, a substance that makes up about 85% of the universe's mass, yet remains invisible to us. Dark matter does not emit, absorb, or reflect light, making it undetectable by traditional methods. Its presence is inferred only through gravitational effects on galaxies and cosmic structures. Physicists believe that the LHC might create dark matter particles during high-energy collisions. If they succeed, it would be one of the most groundbreaking discoveries in modern science, shedding light on one of the universe's greatest mysteries. Some theorists suggest that dark matter could be linked to hidden forces or even hidden civilizations existing in parallel realities. Could the LHC reveal a deeper structure of reality that connects our universe with another?